Hi, and welcome to Geeks for Geeks. Today, we would be doing the GFG Weekly Coding Contest 89 post contest analysis. So, hi, I'm Siddharth. I am a mentor and as well as an SD at Geeks for Geeks. I'm a candidate master at Code Forces. So, give me a quick one if I'm audible as well as equally visible. So, we would start in the next 1 minute, I suppose. So, I would just check. Hi, Thains. Hi, Raja. So just give me a quick one if I'm visible as well as equally audible. Okay, okay. आज भी दिल ले लेना भैया. Okay. First question was wrong. Okay, yes, you are. Okay, thanks a lot. Thanks a lot, Purtik. Thanks a lot, Shubham. Okay, please don't spam. Second was not sliding window. I would tell you why. So let me first see opening. Second was map. No, it was map, but the map one was not intuitive to be honest. So now I would be presenting the whole screen of mine, entire screen, and there we go. Okay, so let's talk about the very first problem. The very first. So today contest. So let's talk about the contest first. Okay, so for me, the first problem was a easy problem to track down if you think. The next problem was a variation of a standard problem. The third problem was from a very underdog topic, and basically, it is a concept which arises many times in competitive coding. But I don't think that the concept that is used in the third question would appear in a interview, but it can appear in a coding contest. Okay, in any online judges problem too. Okay, so now let's talk about this. Yes, so I would make the orientation go big. Yes, I'm fine. Okay, so now let's talk about the very first problem. Mhm. Okay, till this point it is fine. So basically, it is this problem is trying to tell us that there is a source and a destination, and the source and the destination is in the array itself. Suppose we have a1, a2, a3, a4, and a5 itself. Okay, so it would be the source and this would be the destination. And the next thing it is told is that the first and the last is already visited. We can visit it. Then we are told that we can only step on the numbers. We can only step on the numbers which is divisible by 2 and 3. 2 or 3. Basically 2 or 3. So it is just like a Mario game. Okay, so Mario game to khela hi hoga. So we would start from this. Okay, and he can take a jump to this one if it is divisible by 2 or 3. He can take a jump to this one if it is divisible by 2 or 3. Okay, so now let's talk about the sample test cases too. Mm, I think the lower one is good enough. No, the lower one has less. So let's take both of them. Okay. So now see, this is the source. So if I just explain you this test cases, then it would be simply easier. So this is the source. This is the destination. This number is divisible by 3. Let's first find out the divisible by 3. So it is told that the first it can jump to this and then it would jump to this. So what is the distance between 2 and 3? The distance between this is 2. The distance between this is 1. So now, if I need to jump 2 and if I need to take a jump of 1, then I should have a capacity of 2. Why so? Because suppose to do the first, suppose I am given an assignment. The first assignment take 3 hours, the second assignment take 4 hours, the third assignment take 2 hours. So I need to see what is the maximum hour, what is the minimum hour to complete one assignment. अगर पहले असाइनमेंट में 3 लग रहा है, दूसरे असाइनमेंट में 4 लग रहा है, तीसरे असाइनमेंट 2 लग रहा है, तो मिनिमम मुझे 4 घंटे तो चाहिए असाइनमेंट के लिए, क्योंकि कोई भी असाइनमेंट आ सकता है, एनी असाइनमेंट कैन कम अप. So we can say the maximum of all this is our answer. So in the same manner, we are told that I can need to take a jump of 2, I need to take a jump of 1. So I definitely need a capacity to take a jump of 2. So now let's talk about the next one. This is the source, this is the destination. Now the numbers divisible by 2 and 3 is none. So he needs to directly take a jump from source to destination. And the distance of this is 2 to 5 1, 5 to 7 1, and then 7 to 9 1. So this is 3. Okay, it's suppose like this, that suppose I am told that I need to study 2 hours, I need to study 1 hour, I need to study 5 hours. My mother has told me. But this means that I should have a capacity of 5 hours to sit so that I can complete all of this. Okay, so now tell me if this thing is clear or not. Why, even if we have 1 and 2, we are taking the value of 2, and why it is 3? So quickly give me a quick yes or no. Do subscribe for daily purity videos. Thank you. Okay, people here are making a promotion too. Okay, just quickly tell me if I'm clear or not. Like how to decide what jump to take not to mention in the question. I have already told you. You can, the first and the last block we can visit it. Okay. So 668, what for this array? Let me show you. See, 668. So 668. So I can, so divisible by, first the source and the destination are already visitable. Source and the destination is done. This number is divisible by 2 as well as 3. So I can visit this. So I need to take a jump of 1. Then again I need to take a jump of 1. Then the answer to this would be 1 itself. Okay. Okay. Fair enough. So now what we can do is we can start from the source. Okay, and we can see the next point. So the next point, suppose this point is 0, this point is 1, this point is 2, this point is 3. Suppose after source the very next point which is divisible by 2 or 3 is 3, then it would be 3 minus this value, 1 2 3 distance. Then suppose the next value is 4, so 4 minus 3. So what we can do is we can just remember the last time we saw a visitable value, and then when we see a new value known as divisible by 2 or 3, then what we can do is we can just simply calculate the difference, and the resultant answer would be stored in the maximum one. Okay, so now let us move to the implementation. I can simply move to the implementation, I think so. Okay, like just remember the last one. Yes, it is the max distance between two good index. Absolutely. So now let us code this and see. So this is basically big O of A, and so we would start int answer is equals to 0, and then we would say initialize the value. Last time we saw a visitable node is 0 because the first visitable node is 0, and then we would start the iteration from 1 because 1 is 0 is already processed. Okay, so now we would say that if the current number is divisible by 2, or the current number is divisible by 3, then answer is equals to max of already what is stored, current value minus the last time we saw the value. Then we would update that yes, this time we saw this value. So we would update the last variable with I. At the end, we would simply return the value of the answer itself. Now let us just compile and run and see how many errors are we making. And this problem is solved successfully. And this is done. So tell me the line number at which you are not able to understand. I would just stop the screen sharing, share the tab instead, Chrome tab, minimum jump, and this is fine. So tell me, do it for 8782778. Okay, just a sec. 878 2728 2728. So now see, this is index 0, this is index 1, this is index 2, this is 3, this is 4, this is 5, and this is 6. So see, first the value of the last variable would be 0. And then we would start, an answer would also be 0. Then we would start the iteration. So is 7 divisible by 3 or 2? No, it is not. Is 2 divisible by 3 or 2? Yes, it is. So current index is 2 and the last index is 0. So we have a better answer as 2. So we would update the answer. And then we would update the value of the last also, because we now saw this here. So now this is done. Then we would go to the index 3. Index 3 is also divisible by 2. So 3 minus the last value is 2, which is equal to 1, which is not better than what is stored in the answer. Next, we would go to 4, but we would update the value of the last. Okay. Then we would go to the fourth. 4 is not divisible by 7. 7 is not divisible by 2 or 3. 5 is divisible by 2. So 5 minus the last variable, which is equal to 2. But we already have an answer as 2. So this won't affect the answer, but this would affect the value of the last variable. Then the next value is 8. So 8 is divisible by 2. So the value of 6, current value minus last value. So last value is 5, which is equal to 1, which is not better than answer. So we won't update anything. So answer to this is 2, and the last updated value of last is 5. Now am I clear with the sample test case? What if the number is not divisible by either 2 or 3? We won't come inside the if condition. We would simply move forward to the next iteration. Bartos, am I clear to you? You were saying a lot of number of times that I need to do for this test case. Am I clear with this test case? Sounds the okay. What if the last number is not divisible by 2 or 3? So give me a quick one if these things are clear to you. We have 73 live viewers at this point of time. Give me a quick like to this video so that the number of likes could be increased and this work could be justified. Give me a quick like to this video. Increase the number of likes. I want the number of likes to be increased. Okay. So we have to do it for array of I or only I? We have to do it for array of I. Why? Because we are told that if the element is divisible by 2 or 3. Okay. So basically we need to consider the element. How do I make out the logic? Basically, I write it down in a pen and paper. I just saw how many times it is jumping, then I saw what is the maximum one, and then we can do it. Yes, to be honest, it is, we can say that it is because of practice and experience too. Okay, it was intuitive. Sir, एक बार और explain करना. Absolutely, but I would deserve a chocolate from you. Okay, so basically it is told that we are given a Mario game. Okay, let's suppose we are given a Mario game. These are the blocks that we can jump. So this is the source, and I want to move to the destination. And we are told that this Mario can only take a jump. Okay, let's suppose I am here and I want to reach my girlfriend's house. Okay, so I can only take a jump to this one, to this one. So I take a jump to this, I take a jump to this, and then I take a jump to the destination. Why? Because destination is already visitable. Okay, so the amount of distance I need to travel is 2. The amount of distance I need to travel is again 2. The amount of distance I need to travel is 3. So I should have a capacity of traveling distance 3 at a stretch. That it is. So basically we are finding all these indexes by just, so basically we are just trying to move to this indexes. So basically if I am trying to jump the value of 2 and 3, suppose I need to walk 2 and 3 distance at a stretch, then I should have a capacity of walking 3. That is how here we are coming to this question. Here we are finding that yes, here I can jump. So I can just calculating the difference between the last point we have jumped and this point. So we are doing this, and then we are updating that yes, this is the last point we have seen. Am I clear, Priya Yadav? I think so, her name was Priya Yadav. Give me a quick one, Priya Yadav. Move to the second question, sir. Absolutely, I would move to the second question. But see, the thing is, this stream is for everyone, and for me, it is not the correct way that I just move forward with some of the students, even though there are 78 people live here. Okay, so I deserve a chocolate from you. Make sure you ask my address too. Just kidding. Okay, fair enough. Now let's move to the next question, magical subarrays. Mhm. This tab, okay, I'm sharing the tab. Let us share the window itself. So I have bookmarked it, Deepak Sharma. I have bookmarked it. I would just tell you after the stream. I have bookmarked it. Yes, this is done. So now comes the most awaited question, which is the magical subarrays. Okay. So now I would just tell you what this is. Mhm. So basically, in this question, we are told that a magical subarray. Let us first define what is a subarray. Basically, a subarray is a contiguous part of the array. Suppose we have A, B, C, then this is a subarray. This is a subarray. This is a subarray. The whole array is also a subarray. This is it. Now the next thing that I want to discuss with you is what is basically a magical subarray. Okay, a magical subarray is a subarray where the count of odd numbers is odd. Like, let me see. Count of odd numbers is odd. Let me just see. Count of odd numbers should be 0. Count of odd numbers is even. Okay, sorry. And now the next thing is this count should be greater than 0. Okay, and we are told to count the number of subarray, good subarray, magical subarray. Basically, this is the question. The whole big poem that is written in the question itself tells me this, that a magical subarray is a subarray where the count of the odd number is even and the count is greater than 0, and the count of the magical subarray in total is basically is what we have to find. Give me a quick one if you have understood this question. Like, question is understood. Can any of us join you to solve the problem, sir? Yes, absolutely. I'm open. Like, for as of now, I'm a working professional, so I code around 1 to 2 problems each day. So if you are open to solving two medium problems each day, then I'm open to this. Okay, but see, I don't want a very big group or something. Only one or two, nothing more. Okay, okay. So now let us go back to this. Here in this test case, we are told that, see this test case. Here the number of odd number is 2, that is even. 2 even. Then 1, 2. Again it is even. Then it is 1, 2 even. 5, 3 even. 2, 3 and 7 even number of odd numbers. 3 and 7 even number of odd numbers. And 1, 5, 3, 7, 4, which is even number of odd numbers. So there are 6 subarrays we can find. Okay. Okay. And the whole array is also a subarray. Okay. So now this is done. That is why it is told that their output to this is 7. So now let me tell you what is the intuition to this. Okay. So now let us observe a pattern here. Okay. Let us take a test case. Now let's take that, suppose if we have 1, then 4, then 6. And let's suppose here we have 3. After this point, see this carefully. If we have again some even numbers like 2, 4, 8, 10, 12. Let me make some commas also so that I can differentiate between the numbers. Okay. So now see a pattern in this. Okay. So the very first brute force approach would be that I would just consider every subarray, count the number of odd numbers in it. If the count of odd numbers is even, I would increase the count. This is the very brute force approach. Okay, I would just take 2 loops. Okay, so let me just code that also. Okay, now what I can do is I can simply say for int I is equals to 0, I is less than n, and I plus plus, and here I would say for int j is equals to 0, for int j is equals to 0, j is less than I and j plus plus. And here we can just consider the sub array from I to j to I itself. Just consider all the sub arrays. Okay, and it would be done. Okay, fair enough. Now let's go back to this. Now the very next one is, let's see, prefix and sliding window won't happen. Why prefix and sliding window won't happen? Because see, the very first thing is that the subarray, the answer to this, can be this also, can be this also, can be this also. So I can simply conclude that length is variable. If the length is variable, then sliding window can't happen. Okay, sliding window can't happen. Why? Because sliding window wants a fixed size. Like sliding window is somewhat like this. Okay, we have a window made up like this, and this window would come here. Like this window would move forward. This window would come forward, then this, then this, then this, then this. Sliding window is not a possibility. Why? Because the answer can be large enough. Okay, length is variable, so sliding window is not an option. Prefix sum is also not an option. Why? I would tell you this also. So I can say that this contributes to an answer of size 1, or contributes to an answer of 1. Then this contributes to the answer of 1. This also 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 contributes to the answer of 1. So basically, there is no use of using prefix sum. Like even if you keep an count of the odd values, it would be this is odd, this is 0, this is 0, this is odd. Even if you take like this is even, this is even. If you make all the odd values 1 and even value 0, then here it is 1, here it is 1, here it is 1. If you just take the prefix sum, 1 plus 1 2, this would be 2 2 2 2. Yes, prefix sum would help, but we won't be able to count all the subarrays. We need something else too. Prefix sum would come into picture, but this won't help to gain the entire solution out of it. बेसिकली प्रीफिक्स सम क्या कर रहा है? प्रीफिक्स सम हमें बता दे रहा है कि फ्रॉम दिस पॉइंट टू दिस पॉइंट it is valid and we can consider it, but prefix sum is not telling us the actual answer. Sliding window won't work and prefix sum won't solve the problem fully. Am I clear or not? Give me a quick yes or no. Give me a quick yes or no. Sliding window you did, but it is a variable size. Variable size sliding window is known as 2-pointer. It is not sliding window. Others, quickly give me a 1. Yes, I have did that only. Prefix sum would work, but it won't give all the answer. That is what I'm trying to say. It won't give the entire answer. Prefix sum would help and it would be the part of the solution, but it won't help you to gain the entire solution. Okay. By the way, this is the first time I have wore something else than black. I realized it just now. Okay, fair enough. So, sliding window is known as, not known as sliding window, it is known as prefix sum, variable size sliding window. So now see, I can say from here that if I remove all of this, see, here we have the source. Let's take the source as left side. And here, this would contribute to the first answer. Then this would contribute to the second answer. This would contribute to the third answer. This would contribute to the fourth answer. This would contribute to the fifth answer. This would contribute to the sixth answer. So basically, we have two endpoints and one of them is moving. Then after that, if we encounter, like let me just show you this also, how I am coming to the conclusion. This is absolute important. Okay, like how you would solve a problem, how to think in this direction is the most important aspect of this post contest analysis. The solution is not important. There is absolutely a very rare possibility that a question of this concept would appear next, but you should learn problem solving out of this, how to solve a new problem. Okay, so basically if you have 3, then suppose if you have 4, then if you have 5, then suppose you have 5 again. Okay, so now let's see this. Suppose we have L. So first we have R at this point, R at this point. So the count of the odd numbers is 1. This is not, so count of odd numbers is not even. Count of odd numbers after this point is even. 1 and 3 is even. So this would account to 1. This would lead us to a solution of 1. Then we would come here. the count is still odd, so we would move forward. The count is still odd, so we would move forward. And after this point, we see that the count becomes an even. Okay, the count is now odd because 1, 3, and 5. 1, 3, and 5. 3 is basically an odd number. So at this point, I need to move forward the 3 to the next odd position. So basically, we are moving L and R according to our wish. So if we are moving L and R according to our wish, then it is obviously a two pointer. So how am I coming to the conclusion that this is a two pointer approach? Are you clear with this thing or not? If you are clear with this thing, consider you have learned a new thing. Give me a quick one in the chat. If you are now able to say that yes, two pointers was intuitive if I had moved in this direction. Okay, just give me a quick one. What about others? The number of live viewers is 84 at this point. I quickly want the number of live viewers equal to the number of likes. The number of likes is still 58. Can you quickly increase the number of likes? भैया chocolate दे देंगे लेकिन sugar free. Yes, absolutely. Give me a sugar free chocolate. I don't want to get fat. Again, sir. Okay. Let us see. So see, here if we come here, we can see. Let's see. Let's see at this point. See, L and R would start from here. So initially we have a odd number. So the count of odd number is 1, which is odd number. So this won't contribute. This subarray won't contribute to the answer. Next we move forward. This is not an odd number, so we won't increase the count of the odd numbers. We would come here. This is an odd number. So now I can say that this count is now 2, which is even. So this would contribute to the answer. So the answer would be incremented by 1. Okay. Now we come forward and the count, this is not an odd number, so count won't increase. Still the count of the odd number is even. So I can say that yes, this is fine and we can increase the number of count. Okay. Now we again move forward. Again, it is an even number. Count of odd number won't increase. So again, we would increase the value. Next time we come across again the next value as 3. Okay. Next value is now 3. Okay. So why is this? I'm not able to pick up. So next value is 3. Now the count of odd number is 3. Okay. Fair enough. This is not an even value. So we need to move forward. Okay. So now I need to make L move forward. So if I move forward, then we have lost one odd. So I would decrease the counter. Now L is again odd. L is again odd, number of odd numbers is again even. So we would increase this counter. Then we would increase the value of L again. Again, we didn't lost 2. 2 is an even number. So the count of odd numbers won't affect. So this is again, the number of odd numbers again even. So we would increase the counter. Then we would again increase the counter. We lost an odd number. So the count of odd number is again 1, which is an odd number. So this won't increase. Now in the next point, odd is still 1, odd is still 1. At this end, we can say that there are 5 subarrays which have a count of even numbers as odd. Magical subarrays is odd. Am I clear with this concept or not? Give me a quick one. I have shown you the entire low and high would never cross each other. First, there is left and right. So first right would come here, then low would come here, follow it, and then it would stand here. It won't cross again. If it won't cross again, then right is iterating over the whole array once. This is big O of n. Then L is again iterating over the array once. This is big O of 2n. Ignoring the constant in big O of n time complexity, this is big O of n. Okay. So how can I move when the count is odd? When the count is odd, we would simply move forward, but we won't increase the value of the answer array. Like it won't contribute to the answer. It might be a it might be a scenario that there is a magical subarray, but it won't contribute to the answer. Okay, fair enough. Thanks a lot, Mushavir. A chocolate and a comment on the video would solve the purpose. Okay, fair enough. Okay, so now what I can do is please explain using four odd numbers. Okay, let us do that also. Suppose we have 1, 3, 5, 7. Here in this point, we have L and R at this point. So initially, the number of odd number is equal to 1 and the value of the answer value is R0. So now we would move forward with the R value. So number of odd values at this point is 2. So this would contribute to the answer. So the value of the answer is 1. Okay. Now we move forward to the next R. So 5. Now the number of odd value is 3, which won't contribute to the answer. Then we would move forward the R. Now R is again 4. So this would contribute to the answer. So this becomes 2. Now in the next point, I can say that L, if I move forward, then I have lost one odd. So now this value is 3. Okay. This value is 3. So if this value is 3, this won't contribute to the answer. So we would move forward again. Okay. Now this value would become 2 because we have lost one more odd. Now number of odd values is even, so it would contribute to the answer. Okay. Now we would again increase the value. Okay. And this would become 1. Okay. So basically the value would be divided by 2. Why? Because once we are considering a subarray L and R twice, 2x. So we need to divide the whole by 2. Now am I clear with this or not? I have explained it the third time. सर आप ही लेक्चर किए हो अब से सारे सारा लेक्चर लूंगा तो एसडी का काम कैसे करूंगा ब्रो. So what about the case when a magical subarrays L and R are somewhere in between the array? So if L and R are somewhere in between the array, then we would have the count of the odd numbers. If the count of the odd numbers is even, we would do simply one answer plus 1, and then we would move forward the value of R. R would first hit the end. So left में even values को right values को multiply नहीं करेंगे. No, there is no multiplication. We only need the count of the magical subarrays. Okay, so now I would start the coding part of this problem. Okay, so I would simply make it, as I'm a lazy person, I would simply make this to A. Okay, fair enough. And then I would say here using LL is equals to long. Simple. Okay, now first I would say LL C is equals to 0. Okay, long int this would be. Let's take long int so that I need to write less. I don't need to write long int again and again. So now I would start the iteration. For int I is equals to 0, I is less than n, and I plus plus. First I would make that if the value is odd, I would assign 1. If the value is even, I would assign 0. Simple enough. So I would say if array of I modulo 2 is equal to 1, then a of I is equals to 1, that it is odd, else a of I is equal to the value 0. And here we would just increase the count also. Okay. At the end, if we have no odd values, then there is no point moving forward. If C is equals to 0, then we would say that answer is not possible, answer is equals to 0. Simple enough. We are just replacing the odd values with 1, even values with 0, and then if we are saying that if odd values is not present only, then there is no point in magical subarrays, because magical subarrays requires the presence of odd numbers. Suppose I want to be in a relationship but I have no girls, so this means that I can't have a relationship. In the same manner, I can say if the number of odd numbers is not present, there is no question of magical subarrays, so I would return 0. Simple enough. Now I would say long temp array of 2. Okay. And this would be 0 and 1. Why 0 and 1? If the value is 0, we would add 1. If the value is 1, we would add 0. Okay, simply. That we don't need to have 0 and 1 again and again. Okay. 0 means add 1, the 1 means add 0. If the number of, like, after dividing by 2, if it is 0, then add 1. If it is odd value, add 1. If it is even value, but this just implies that 0 would add 1 to the answer and 1 would add 0 to the answer. So what we would basically do is we would basically divide the number by 2 and directly add the value of temp. So if the value is 0, 1 would get added. If the value is 1, 0 would get added. Simple enough. Now here I would come to the value. So long result is equals to long result is equals to 0 and sum is also equals to 0. I would copy the value of the result so that I don't need to write result again and again. Okay. And here I would say long CNT is equals to 0. Fair enough. I don't think I require long int. I can just use long everywhere. Okay. Fair enough. We come to this point. And then we would say int I is equals to 0 and j is also equals to 0. Basically right and left. Okay. So while the value of right pointer is less than the boundary, while j is less than n. Okay. And then I would say if a of j is equals to 1, if it is an odd value, then I would say I is equals to j plus 1. Else we would say that the value of count would get increased by I minus j plus 1. Okay, this is basically the length. Suppose we want 0, 1, 2, 3. So 3 minus 0 plus 1 would give me the length of this. That is what we are doing. We are adding the length. Okay, so bigger value minus smaller value plus 1. And then we would simply increase the value of j plus plus. At this end, now we would come across the point where we would add the values. Okay, so for int I is equals to 0, I is less than n and I plus plus. I is less than n and I plus plus. Yes, absolutely. Now I would say sum is equals to sum plus a of I, okay, modulo 2 plus 2, and then the bracket and whole modulo 2 itself. And then we would say temp of sum is equal to plus plus at this end. Okay. Now after this point, I would say result plus equals to result plus equals to the value of temp array. Okay. The value of temp array, temp of 0, okay, minus 1. Like we have counted every values multiplied by 2, so we would divide by 2, count or temp of 0, okay, multiplied by temp of 0 minus 1 divide by 2. Okay, so n into n minus 1 by 2, and here we would again add the result of temp of 1. here it would be temp of 1, and then again 1 minus 1 divide by 2 itself, and then we would return the result of result minus count, and this would be done. Now let us just compile and see how many errors am I making. I should make some errors, like some long sum 4033. Okay, let's add one more. Okay, I think we are done. Yes, we are done. Just tell me the line number at which you are not able to understand. Okay, could you when a magical subarray is in between, this is done. 1 2, we aren't considering 2 5 2 3. Why aren't we considering 2 3 2 5? We are considering it at the end. So basically just see what I'm trying to say is, see. Don't worry, I would just present the whole screen and this would be clear. So see, it is just like this. Suppose we have 1 2 3. So the number of possible subarrays is n multiplied by, so the number of possible subarrays, let us count this. So this is 1 plus 1 plus 1 plus 1, size of all subarrays of size 1. Then 1 2 3 4. So basically size 2 subarrays is 1 2 3. 2 plus 2 plus 2. Size of the subarray of size 3 is this and this. So 3 3. That is why we are doing n multiplied by n plus 1 divided by 2. Okay, this is the value. First this one. So see, 4 multiplied by 5 by 2 is equals to 2. There are 10 subarrays that are like this. See, count the number of subarrays. 1 2 3 4 5 6 7. 1 2 3 4 5. 1 2 3 4 5 6 7 8 9. So 3 4 5 4. Okay, the whole array is also a subarray. So 9 subarrays of 1 2 and 3, and the whole array is also subarray. 10. This is that is why we are counting this point. We are counting the number of subarrays divided by 2. Now let me give you a walkthrough of code. First, we are replacing the odd with 1 and even with 0. Replace the array elements. If odd, then equal to 1. If even, then equal to 0. First, we are doing this. Okay. Then at this point, we are using a temp array so that I can simply use this value. If if no odd exists, then no magical arrays. Okay. Now we are initializing all the variables with 0. And then we are saying j is less than equal to n. This just means that it should be within, like the pointer should be within the array index. Okay. Then we are saying that if array element is odd, we would move forward. If odd, and here We are saying that if even, then we would simply count the value. If odd, then we would move the value. If even, we would simply count the number of variables. Okay. Now at this point, we are saying that the sum we have produced is even or odd. So sum is even or odd. Okay. Now, if it is even, then 0 would get added. If it is odd, then if it is even, the value is 0, then 1 would get added. If the value is 1, 0 would get added. After that, I have already explained you this. This is because of this. N multiplied by n plus 1 by 2. Now am I clear with the walkthrough of the code? So just a quick, can you please explain the walkthrough of the code? Now am I clear? Explanation इतना easy लगा, code तो ऊपर से जा रहा है. Yes, in code we are bound to handle all the edge cases. Everything just binds together. And in code, I can't take explanation. Like I can't do much explanation. Like a is equals to 5 or 3. Okay. Jitni so left multiplied by left wali wise jitni hui na? Yes, absolutely. Now am I clear? Give me a quick one. Did you use cadence algorithm here? No, I used two pointers algorithm here. Just replaced all the odd numbers with 1, even values with 0, and that was done. So now tell me if things are clear to you or not. आई एम लेट वर्ड आज क्या टॉपिक है? आज पोस्ट कॉन्टेस्ट एनालिसिस का टॉपिक है. In the first loop, what is the value of why do we have j plus 1? So like I would directly come to the value of j plus 1. Like suppose if we have odd number of even values, odd number of odd values, then I should come at this point. Then from this point we should start considering, because we have already considered this all point. So just let me shift the Wi-Fi. Okay, so now the video should not be paused enough. Chalo, let's move forward. Now, am I clear with the audio or something? Okay, next is a very important question. Okay, so just read the problem before I move forward. Powerful node. This is a hard level question for me. And maximum white subtree. This question is inspired from this question. This question is inspired from this question. Maximum white subtree. Basically, from this question only, this question is inspired. Okay. This question is inspired from this question. Now let us move back to this problem. Div 2f question. Like I have already solved this problem when I was learning about rerouting DP. on code forces. The rating of this question is 1800. This question is inspired from this question. I already gave this concept, like I already gave this concept a try 1 year back, and then I used this question as a practice question, like a question for learning. So am I done with the question? Now let us start move forward. Yes, absolutely. Rerouting DP has normally two DFS operation. No, basic math was not required. But rerouting DP is very interesting as well as an easy topic to understand. So see, now in this question, first let us see how the answer is coming up. Okay, let us add this in a new tab. And then let's go back and let's see this. Okay, so see, in this question, we are given a tree but not a rooted tree. See this question, not a rooted tree. It is connected, undirected, no cycle. So everything is true, but the thing is, it is not rooted. This is the first indication, not rooted. So the very first indication is the question. In this question, we are told that it is not rooted. The very next question is that a 2D array where I and j means that there is an edge from I to j. And then there is told that the power of the ith node, okay, power of the ith node is the distance multiplied by the value j, I to j, for all j to 0. Okay, so now let us build this graph. So we have a value from 0 to 1, and then 1 to 2, then 0 to 4, then 2 to 3. First we have this. And where we are routing this, let us see this from power of the node 0 is 0 into 1. Okay, we are moving forward from 0. Okay, so now see, power of the node from 0 till the value of 1 is distance of I and j, 0 to 1, 0 to 4. Distance of 0 to 4 is 1 multiplied by j, that is 4. So this value is 4. Then 0, distance of 0 to 1 is again 1 multiplied by 0 to 1 is 1 again multiplied by 1, which is equal to 1. Then 0 to 2, distance is 2 multiplied by the value, that is 2. That is why the value of this is 4. Then we are told the distance of 0 to 3. So distance is equals to 3, 0, 1, 2, 3, and the value j, that is 3. So that is why the value to this is 9. So basically the distance is the number of edges that we have in this place. Okay, and then multiplied by, suppose we have an edge from x to y, so it would be the distance from x comma y multiplied by y itself. Simple enough. Now, am I clear with the problem statement? First tell me, then I would start explanation of this problem. First tell me if this question is clear to you or not. Give me a quick one if this question is clear to you. Give me a quick one if this question is clear to you. Okay, thanks a lot. Now let us move back. Now in this question, you can see that let's take the value. Suppose this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So now see, the value from 0 to 4 The distance is distance of 0 to 4 multiplied by I to j multiplied by j. 0 to 4. 0 to 4 the distance is 2 and the value is 4, which is equal to 8. But now suppose if we are moving from 2 and the distance of 2 to 4 multiplied by 4. 0 2 to 4 distance is 1 and multiplied by the value of j, which is also equals to 4. 1 multiplied by 4 is 4. Then 2 to 0, the value is d. 2 to 0 multiplied by the value 2. 0 to the distance is 1 multiplied by the value 2, which is equals to 2. So as you can see that changing the source makes a lot of difference. Like suppose if we calculate all the values from 0, the answer would be different. If we calculate all the values from 2, the answer would be different. If we calculate all the values from 6, the answer would be different. So from where we are propagating, it is very important. Okay, like suppose to learn coding, if you are starting from Python, if you're starting from Java, if you're starting from any other, then the pathway is different. In the same manner, if you consider different branches, then we can say that yes, the values are different. Am I clear with this or not? Considering different source is equal to different answers. Considering different points of propagation is equals to different answer. Am I clear with this or not? Okay. Considering different propagations. So now let us go back. See, what we can do is first see this. Suppose this is equal to 1. Now let's say that initially the parent is 1. So source of propagation is 1. And this would be 2, this would be 3. Okay, this would be 3, this would be 4, this would be 5, this would be 6, and this would be 7. So initially let's say that the maximum answer would come from this. Let's say. Okay, and let's first code till this point. How would we code this? So how we would code this? We would just calculate the difference. So we would calculate the distance. So initially the distance of 1 is 0. Okay, let me just show you how would we calculate the distance. So distance of 1 is 0. When we are visiting the neighbor, distance of 1 plus 1. Distance of 1 is 0. 0 plus 1 is 1. Okay, in the same manner, 3 would also be considered with the distance of 1. Then 3, distance of its parent plus 1. Distance of its parent is 1 and its child is 1 plus 1, that is 2. Distance of parent plus 1, that is 2. Distance of parent plus 1, 2. Distance of parent plus 1, that is 2. Okay, this is how we would find the distance. Okay, so we would just find the distance. We would just find the power of all the values and then we would take the maximum. So a simple DFS from the root would solve the purpose. Okay, now let's move to first say that the maximum answer would come from this rooted tree. Let's say that the maximum answer would come from this rooted tree. Let's suppose say this. Okay, fair enough. So now let's first code this. Code till this point. Let's first code. Otherwise, you would be like code and you would get disconnected and you would say that I am not able to understand the coding part. So now let's take, we would just say that this is a value E. Okay. So now what all things we need? We need a vector of vectors to make the graph, because we are not given the graph, we are given the edges. So int g, and then we would say using long is equals to, okay, like we do basically. So we need to build a graph, so that is why we require data structure to do it. And then we would say long mx, that would store the maximum answer, and this would store the variable. Why? Because we are told that suppose 2 and 3 both have the value as 5, then 2 would be the answer. Why? Because the value of the node is small. So max would store the value. So mx would store the value and answer would store the node value. Okay, fair enough, simple. And then we have a vector of ll, and we would say dp comma size. Why? Because size would store the value of the distance, and dp array I would explain you later part when we would talk about rerouting. Okay, so now first we would talk about the first dfs array. So dfs array would say wired dfs1. Why? Simple enough. Then then the node u and its parent. Okay, we have done it. Then the size of u is equal to u, and dp of u is equals to 0. Initially we make the value as 0. Then we would iterate on its neighbors. Okay, so auto iterate on the over all its neighbors. Auto v of g of u. Now if we are, suppose this is the parent, suppose from 1 we are going to 2, but 2 shouldn't move back to 1. So we would say if the neighbor is not the parent, like from parent we are moving and again we are going back, so that is again a big problematic one. So if v is not equal to, the parent, okay, v is not, like what I'm trying to say is, like, let me just stop the sharing part, let me share the screen. What I'm trying to say is that in this, suppose we have the root node as 1, and then it is 2 also, then it is 3. The parent of 1 is 2. But suppose from 1, the neighbor is also 2. So again, we are coming back to the top one, but we don't want to do that. We want to go down. So to go down, we are saying that if it is not equal to the parent. If it is not equal to the parent, that means we are going down, and this is what we want. So dfs of 1 with the neighbor, and this time the parent would be v of u, and then we would say the size array of u plus the size of v. Okay, and then we would say the distance of the parent node plus the distance of the current node. So dp of parent node, distance of the parent node, plus the distance of the child node, and the size itself, because we are told that multiplied by this. Okay, so size is v itself. Okay, fair enough, we are done. Now let's just build up this graph, and then we would talk about the rest of the question. So g dot clear, let's suppose some different test cases are made here. Then g dot resize with the value, like g would get resized with the value of n. Then dp dot resize, first we are resetting all the values. Okay, reset is done. And size also we require, size dot resize with the value as n. Okay, now we would build the graph. For int I is equals to 0, I is less than n, and I plus plus. And then we would say g of p of I 0 dot push back the value of g of I dash 1. Now in the next part we would just do the reverse. Like if there is an edge from A to B, there is also an edge from B to A. Why? This is an undirected graph. So A to B, 0 to 1, there is an edge. Now 1 to 0, there would also be an edge. Okay. Now there is also an edge. Now we would say the maximum value is 1 and the answer is also is equals to -1. And then we would run the DFS1 with 0 as the parent as -1. Now this question is complete. Okay. So now am I clear with this part or not? Like I would stop the screen sharing, share the tab instead, and tell me if this till this point it is clear or not. Like if we know that the maximum value would come from one only. If the maximum value would come from one only, then it is true or not. Okay, so first tell me if this thing is clear or not. Give me a quick 0 and 1. If you have understood, give me a 1. Else mention the line number at which you are not able to understand. Give me a quick 0 or 1. Give me a quick feedback so that I can move forward. Give me a quick feedback so that I can just move forward with this problem. Why are others not replying? Only one is saying at this point or not. Okay, so I'm trying to do my best. So I think I can move forward. Okay, now let's suppose that this time first we are considering the root as 1. Now we need to change the source because changing the source produces different answer. Like suppose I have a value as s1, s2, s3. If I consider one s1, then the value is different. If I consider s2, the value is different. If I consider s3, the value is different. So I need to consider each of the values to get the maximum value. So in the same manner, I need to restructure the tree and I need to move forward. How to restructure? Now what I need to do is I need to change the source. Basically need to change the root. So this is known as rerouting DP. Okay, this is known as rerouting DP. If you want to read about it, you can read about it. Okay, like there is not much resources. This is a very underdog topic, but a very important topic in competitive programming. You can read about it. Okay, so now let us see what would be the scenario when the root, like this is the tree, first tree. What would be the scenario when the root is 2? When the root is true, okay, when the root is 2, when the root is supposed to, then we would change only one segment. Okay, we would change only one segment, that is this edge. Okay, we need to change this edge. After this edge is done, this is a complete tree with the root as 2. If we change this edge to this side, like from 2 it is emerging, then this is a tree rooted at 2. Okay, now in the next iteration, suppose I want to change this. Okay, like we need to take the copy of this one only. Okay, suppose this time I need to make the root as 3. If I want to make the root as 3, then I just need to change this to this, and now the root is 3. But this time this 2 is to its original form, so we need to first change the root change the root change the root change the edge. Like change the root is basically Okay, this is to its original form. Like if you see 2 is again back to its original state, then only just one edge is required. Otherwise, we need to change this also, this also. So I can say that first I need to change direction of edge, and then I need to revert back after the task is complete. I need to revert back to the original state that was already there. Okay, this is the two things that we need to do. Now if the root is different, then we don't need to recalculate all the values. Why? Initially from 1 to 1 the value contributing was 0 and others were contributing. This time if the tree is rooted as 2, then this value would be 0 and now 1 would contribute. So 1 would be taken into account and this won't be taken into account. Similarly, if we want to make a transition from this point to this point, remove the contribution of root, add, like remove the contribution of children. Okay, sorry. Remove the contribution of the new root and add the contribution of the old root. These are the two addition and subtraction I need to do. So first I need to change the direction of edge. After I have changed the direction of edge, the root is now changed. The root is changed, then we need to remove and add the contribution and we need to process our result. Then we need to revert back. This is what is known as rerouting DP, and this can be simply done by a simple DFS. So again, let us sum up everything. So we saw that to change the root, we just need to change one edge. After changing one edge, we remove the contribution of the new root. Like, okay, we remove the contribution of the this one. Like after this, to root, the value would be 0. It is told that the root to root, the value is 0. Root to root, the value is 0. So root to root, the value would be 0. So we would remove the contribution of the new root. Then we would add the contribution of the old root, and this is done. Now we saw that when we are moving forward and we are making another node as the root, then now these time two changes are required. If this was the tree, then only one change is required. If this is the tree, then two changes. So what we can do is we can simply revert back so that only one change is required every time. Otherwise, one change first, two change second, third change fourth, and the number of changes would stack up. So basically, I don't want the changes to be stacked up. Okay, like suppose मैं कुछ बिगाड़ के गया, अगला आदमी, suppose my friend comes and empties the water bottle to this level. Then I come back and again I empty this water bottle to this pack. But what I'm trying to say is, suppose my friend did this mistake and drank the water bottle. Then in the next iteration, he should again fill up the bottle so that in every iteration, the amount of water would go down and the amount of effort required would be less. So to decrease the amount of effort, I need to revert back. So after changing the root, we need to add or remove the contribution, and this would be done. Am I clear? May I move forward to the next coding of DFS, just the rerouting part? Can I move forward to the rerouting part? Just give me a quick 1 or 0 in the chat. Okay. Now I would move forward to the rerouting part. Now I would say the void dfs2, and here also we would have the same int u and int p. Okay. Now I would say if we have a better value, okay, if we have a better value, if dp of u is greater than equal to mx. First, if 2 and 3, if suppose 2 has also a value 3 and 3 also has a value 4, then we would require the minimum, because it is told if if two nodes have the minimum same value, then the minimum one needs to be reported. Then we would say if dp of u is equals to mx. If this is the scenario, then we would take the minimum. Answer is equals to minimum of answer array. Okay, answer array, and then ll, long u. Okay, this is done. Else we would say, else we would say that answer is equals to u. Like this is greater, so answer is equals to u. And at the end, mx is equals to dp of mx is equals to dp of u. And this is done. Now, after this is handled. So we would simply comment this out. After this point, we would say that we would iterate on all the neighbors from the root. So auto v of g of u, and we would draw the same condition while v is not equal to p. Like we aren't going back. I've copied the condition so that you know from where this idea is coming up. First, we remove the contribution of the root. So what is root here? Root is u. So we would say dp of u minus dp of v plus the size of v itself. Then we would remove the size also from the root. Size, root is u, so size minus is equals to size of the children. Then we would add the contribution of the children. So dp of v add to dp of the parent, and then the size of the parent. In the same manner, the size would also be differentiated. So size of v added to size of u. Okay, this is done. Then after that, we would do our work. What is dfs of 2 of v of u? Okay, first we are restructuring the root, then we are processing it. Whatever is needed, we would do it, and then we would put back the things that we have done. So instead of subtraction, everyone would be addition. Instead of addition, the values would be subtraction. So size of v minus the size of u, because here we have added it, size of v plus u. So size of v minus the value of u, dp of v minus dp of u plus d. Okay, and then size of v minus u, dp of v minus u, and then let's talk about the u. Size of u, earlier it was negative, it would be positive. Size of u added to the value. Whatever we have subtracted, these two values we have subtracted, these two values we are adding again. These two values we have added, these two values we are subtracting the value again. And that is done at this point. Then we would simply call the restructuring dfs2, and this would be done. So dfs2 with the value of 0 and minus 1, and then we would return the value of the answer. Simple enough. This is known as rerouting dp. So dfs of 1, this would be. Okay, so seems like I made a mistake somewhere. Long mx vector of long dp comma size, and then we have u to p, then dp of this is equals to this. Okay, dp is equals to mx, then long u, else answer is equals to u. If v is not equal to p, then we would simply return the value d of u minus d of dp plus size of u, size of v plus u, v with the value u, size of v minus the size of u, dp of v minus dp of u, comma size of u, size of u minus size of v, dp of u. Okay, then we would say dp of u is equals to 0. V is not equal to parent, then v of u, dp of u plus size of v. Then here we would every time g of resize of n, size resize dot n less than n minus 1. We are given n minus 1 results. Yes, n minus 1, and that should be it. Edges of g of e of I of 0, then e of 0 comma 1. This would be e of 0 comma 1. I was able to debug. Now let us see. 1 and 0, mx is equals to 0 and 1. And then we are calling out the DFS 1 and DFS 2. And then we would just compile and run and see. I think I need to refresh it. Since we are reversing the option 33 to 36. 33 to 36. Oops. Sorry. Yes. Okay. Now let us write the conditions again. Okay. Like size of v minus is equals to size of u. The same but the opposite. dp of v minus is equals to dp of u plus the size of u. Yes, this is correct. We are not processing anything before. We shouldn't process anything before. This is the idea. So size of u added to size of v. Basically, I just copied the lines from upwards. That is why this happened. dp of u plus is equals to dp of v plus size of v. The same thing, but the reordering is done. Size, dp. Yes. Now we should have the correct one. Yes, absolutely. A lot of silly mistakes being done at this last question. Because for the last 1.5 hours, I'm just processing the result. I want this to be processed more fast. Okay, you can see the result. Just tell me the line number at which you're not able to understand. Basically, we would wait for this one because this is the one we have coded just now. So I would just stop the screen sharing. I would just share the Chrome tab, powerful node, and still this is processing the result. I don't know why, but the result is correct. Where can I get your code, sir? Basically, what you can do is you can just text me on LinkedIn for my code. So I would be just sharing my LinkedIn. Just text me on LinkedIn and I would give you this. This question practice में आएगा, ये question बाद में. Yes, absolutely. This question won't come to practice, but you can go to the problem page and then you can just do it. But basically, it might be a scenario that if the question is getting good number of hits or good number of likes, then this question would come to the practice session. Now, the very next thing is Sir, contest okay. So any more queries you have? Something went wrong. It might be because either your submission is taking too much time or there might be internet issue. Check your submissions tab. Let me just refresh it again. Hard refresh, then submit, and this should work. Yes, it is now done. Hard refreshes. Okay. Any more queries you have? I would be waiting for the next 30 seconds and then I would be turning off this session. The last rerouting DP part is shown because the DFS part and the building of the array is already done. Just so if you were here till this point of the solution, and if you are able to take at least a small point of it, it might be a scenario that I made mistakes. Just let me know. Okay, so that I can just improve better. So where to practice these type of questions on Geeks for Geeks or Read Code, not Code Forces, please. You can practice at Coder. You can practice questions from at Coder. They have absolutely great problem set. They don't have any storyline. The problem statement are at max 3 to 4 lines, and they are absolutely great for interviews and all. Okay, that was it from my side. So if you were here till this point of the video, so you saw the video for the whole point of time, either give your feedback, or if you liked the video, consider giving me a positive feedback. If you give me a positive feedback, it would boost my energy. That was it for today. Thank you and have a nice day. If you're watching the stream in the recorded version, feel free to like and comment the video so that the reach of this video could be increased. Thank you, everyone.